Hey students, it's Mrs. Beamer again. This lesson is writing quadratic functions and models. So we're taking these three forms that we've learned, and we're going to be given some information, either a graph or some points, and we will have to write an equation from those. We'll have to determine which of the three forms is appropriate and then write it. So one hint, you're always going to use vertex or x-intercept form. Unless it says write it in standard form, then you're going to use vertex, x-intercept, and then you would switch it over to standard form if you wanted it in standard form. But these two are our much easier ones to use. So looking at this, I'm given a vertex here at 2, 0, and another point, 3, 1, and it says to write a quadratic function in vertex form, which would make sense knowing that we're given the vertex. So let's write out our three forms first of all. Standard is y equals ax squared plus bx plus c. Vertex is y equals a times x minus h, the quantity squared, plus k. And then x-intercept form is, I'm going to write it above it. My writing area is really small right now. It's y equals a times x minus p times x minus q, where p and q are our x-intercepts. So to write this problem in vertex form, I first need to know what vertex form is. So y equals a times x minus h squared plus k. Again, if you can't just write that down, you don't just know what the form is, you should study those. Rewrite those forms over and over again until you have them stuck in your head and memorized. But there's my vertex form. So my h and my k are here, and here's an x and a y. And I can plug those all into the equation, and that will leave me with just an a that I need to find. So my y is 1, my a is what I need, my x is 3, my h is 2 squared, and then plus my k is 0. So again, I knew that this was h and k because it's my vertex. H and k stand for the vertex. So that's why I knew to plug those in there. So simplifying, I have 1 equals a times 3 minus 2 is 1 squared plus 0. I can just leave off the 0 because it's a 0. And so then I have 1 equals a times, well, 1 squared is just 1, so a times 1 is 1. So my equation, y equals a is 1 times x minus h is 2 squared plus k is 0. So I knew I wanted to leave my x and my y in there because a general equation has an x and a y. But now I need to do a little simplifying because this 1 on the front right here, that 1, well, 1 times anything is itself, so we don't need the 1. And adding 0, well, that keeps the same exact equation as well, so we don't need that one there either. So our simplified form would be y equals x minus 2, the quantity squared. And a good way to check that would be to plug this equation into y equals in your graphing calculator and check the ordered pairs. Make sure those two ordered pairs are on there. All right, our next one, write a quadratic function in x-intercept form. And that makes sense here because we have an x-intercept here at 1 and an x-intercept there at, let's see, 2, 3, at 4. Then we have one other point, so that is going to be an x and a y. So there's my p and my q. You can switch it around. That could be q and p. It doesn't really matter, but that has to be x and y. So my x-intercept form is y equals a times x minus p times x minus q. Again, if you don't have that memorized, you can't just write it. You should study that. So this is my x and my y, and my intercepts are positive 1 and positive 4. So there's my p and my q. So y is negative 6. A is what we have to find. My x is 2 minus 1 for one of my intercepts. And the other is 2 minus 4 for my other intercept. And again, remember, intercept form has these opposite signs in here. So this is a positive 1, I want a minus 1 here. This is a positive 4, I want a minus 4 in here. These have to be the opposite signs of what these are. Key thing, common mistake made there. So now we're going to simplify this, and then solve for a. So I have negative 6 equals a times 2 minus 1 is 1, and 2 minus 4 is negative 2. it's negative 6 equals a times a negative 2. I got to get rid of that negative 2 so I can solve for a. So I have a equals a positive 3. So my equation is y equals 3 times x minus, one of them is 1, and then x minus 4. And you could switch these around right here. That could be x minus 4 and x minus 1. You got to have the correct signs though. And a way to check this would be, again, to plug it into y equals in your graphing calculator. Look at the table and make sure that this point and then the point 10 and the point 40 are all on that table. All right, these ones don't give us as much information. They don't tell us specifically what to write it in, but it should be simple because it says write a quadratic function whose graph has a vertex at this and passes through this point. If we're given a vertex, we're going to write it in vertex form. All right, so vertex form, y equals a times the quantity x minus h squared plus k. So here's my vertex, here's my h, and my k, and here's my x and my y. So y is 1 equals a times x is negative 1 minus k is a negative 2, so I have to put h is a negative 2, so I have to put plus 2. Opposite sign there, squared, and then plus k is 3. So again, that trick there, h was a minus 2, this has a minus a negative 2 will become plus 2. So be careful of that. All right, so I have 1 equals a, and then I have to simplify this. Negative 1 plus 2 is 1 squared plus 3. I have to follow those order of operations. So I have 1 equals a times 1 squared is 1 plus 3. Subtract that 3 from both. I have negative 2 equals a times 1, which is just a. So my equation for this one is y equals negative 2 times x plus 2 squared plus 3. And again, you could plug that in your graphing calculator and make sure that when this is put into y equals, you have these 2 points on that graph when you check the table. All right, my last one, write a quadratic function who has x-intercepts at these 2 points and passes through, here's an x and a y, a point. So x-intercepts tells me I am going to use intercept form. So here's my p and my q and my x and my y. So intercept form is y equals a times x minus p times the quantity x minus q. So y is negative 4. A we do not know, we leave it a. X is negative 1. P is negative 2, so I'm going to put plus 2 because again, I've got this minus p, so I got to put the opposite sign there. Minus a negative 2 would become plus 2. And then my other x is, my x is still negative 1. And my q is a positive 1, so that's going to be minus 1. And again, that's the trickiest spot. That's a positive 1, so minus 1 stays minus 1. Now let's simplify. Negative 4 equals a times negative 1 plus 2 is 1. Negative 1 minus 1 is negative 2. So I have negative 4 equals a times negative 1 times negative 2 is negative 2. Divide both sides by negative 2, and a equals a positive 2. So, let's see, let's see if I mixed up a sign there. No, looks right. I think I got my right sign on there. So my equation is y equals, a is 2, and then the quantity x minus, or plus 2, because mine's a negative, becomes a positive 2, and then x minus 1. I'm just going to double check my work here, just to make sure, because I had a different answer on my page. I want to double check. So minus 2 becomes a plus 2, a positive 1 is a minus 1. I plugged a negative 1 in for both of my x's, and a negative 4 right in here for my y. Negative 4 equals, that together is positive 1, that together is negative 2. Divide both sides by my negative 2. Negative 4 divided by negative 2 is positive 2, so that's correct. So again, plug it into y equals in your graphing calculator and make sure that that point's on there and that these two are your x-intercepts. So that should be negative 2, 0, and 1, 0 as well. And that's it for this lesson. Have a great night.